Morning to everyone. This is Avari Sri Aditya Bharadwaj, 24BQ180410, and I am going to give about seminar topic register, registers and the classification and overview. Here we see what is register. Definition: a register is a fundamental component defined as a group of two or more flip-flops used to store multiple bits of binary data. Suppose we have to store some value, so we have to use flip-flop. If we use more flip-flops, more than one, more than two or more, then it will store multiple bits of memory. Then the element which stores this all is known as registers. Each flip-flop within the register stores a single binary bit that is 0 or 1. Provides temporary storage for data during processing. Facilitate data transferring between different parts of digital circuit. Operation is done by clock signals. Is we know that. Let's see, this is flip flop 1, this is flip flop 2, this is flip flop 3, and this is q1, q2, q3 are the outputs. There are several data types which takes input and output. Let's see the methods, which data input methods. Classification overview. Many classification of registers based on data input and output methods of registers. One is SISO, that means serial in, serial out. Another one is SIPO, that means serial in, parallel out. Another one is parallel in, serial out, that is known as PISO. Another one is PIPO, that is known as parallel in, parallel out. Okay, we will see one by one. Yeah, another thing. Here, depending upon application, these are classified into two types. One is shift register, another one is storage register. Yeah, shift register takes three. One is SISO, another one is SIPO, another one is PISO, and remaining one takes PIPO. That we'll see one by one clearly. Here, see definition of serial in, serial out. Here, data enters and exits one bit at a time sequentially. Operations, we know that clock signals requires n clock pulses to load n bits. Each pulse shifts data one position. Application, used as time delay element in digital circuits. Yeah. Let us see the output. Yeah. See this input here, D1, D2, DT, D3 and D4 are the inputs. Here Q1, which is Q1, this is Q2 and this is Q3 and this is Q4 are the outputs. See, they are connected in series. So this is known as series input and series output. The entering data is in series and output data is also in series. So it is known as series input, series output. And now we will see about series serial in and parallel out. Definition: a register that accept data bit by bit serially and outputs are bit simultaneously in parallel. Operation: data enters serially, one bit at a time. With each clock pulse, data propagates through that chain. After n clock pulse, an n bit word is loaded. Applications: series to parallel data conversion, communication interference. When you see here, the yeah here DA is the input, DB is the output, and DC is the input. Sorry, DD is also input. Here DB is also input, and QA is the output, and QB is also output, and QC is also output, and QD is also output. Did you observe here all DA, DB, DC, DD are connected in series, and see here QA, QB are in QC, and QD are in parallel. So this is known as serial in and parallel out. This is comes under a shift register. And parallel in, serial out. Sorry, here PISO. PISO. Definition: a register that accepts data in parallel and output it serially, controlled by a shift or load line operation. Load here, load state and shifted both to have, let's see, clarity. What is meant by load state and shifted? All bits loaded simultaneously in load state. Shifted data shifts out one bit at a time, requires n clock pulses for n bit word. Application: parallel to series data conversion and reduce data transmission. Please underline, please excuse me for this PISO, not PIPO. Here we use and NOR gates, complement line, normal line. This is known as complement line. This is known as normal line, and we have parallel in, parallel in. We have parallel in parallel input. That means parallel in and we have a serial serial output, serial out. So we define this as parallel in serial out. And now we discuss about parallel in, parallel out. Definition: the parallel in and in out, parallel out register is designed for rapid data storage and a retrieval with simultaneous parallel input and output operations. When it comes to operation, all bit of data word are loaded into the register simultaneously with a single clock pulse. All stored bits are available at the output simultaneously and in parallel, typically within the same clock cycle for both input and output. PIPO, parallel in, parallel out registers are the fastest type of register for data storage access. Applications: we have several applications. Temporary storage buffers within digital system, data holding between different stages of processing unit. And this is the diagram. for parallel in and parallel out. And the summary of this is classification of summary: serial in, serial out. SISO input method is serial, output method is serial. Typical use case: time delay element, simple data storage. When it comes to serial in, parallel out, SIPO, input method is serial, output method is parallel. Serial to parallel data conversion, we use this type of register. And parallel in, serial out, input method parallel, output method serial. Parallel to serial data conversion we use. And parallel in, parallel out, input method parallel, output method parallel. We use in a temporary data storage buffer latch. Thank you. 24BQ 180 410.